This is the Sprint 3 video for Team USMA GVR Bot AY17-1.
This team consists of Cadets Tan, Bansky, Moffitt, Vosberg, and Uhara. Here you can see our product roadmap. We are currently in Sprint 3. This is a blown up view of our product roadmap for this sprint.
This sprint, we focused on evaluating our subsystems for data measurement through desk tests. Challenges we encountered included only having one working GVR bot when we planned to have two. Here you can see our sprint backlog. A copy of the sprint backlog can be found on our Trello board. Incomplete tasks include the speed test trials, the load capacity test trials, getting the second GVR bot to work, and acquiring the second GVR bot. This is the burn down chart for Sprint 3. Our capacity for this sprint was 123.75 hours. We've completed 141.5 hours. Our inability to complete the test trials for speed and physical load account for the incomplete hours remaining.
For our individual tasks, we have included our sprint goal at the top and have color coordinated what tasks accomplished with which part of the sprint goal.
We will now go through a demonstration of our configuration and test-taking environment for desk tests.
This video is a desk test demonstration of the battery state test, Trial 2, conducted on 7 December 2016. As you can see, GVR Bot runs on a desk test as connected to the battery, PCB, Raspberry Pi, and a multimeter. First, we initiate the ROS code on Linux computer. On the computer, we first open the supplement file, followed by a command prompt window. After connecting the GVR bot to the Wi-Fi of the computer and successfully pairs, we can then copy this line of code to the command prompt, successfully pairing the robot to the computer itself. This will open a GUI screen of the GVR bot. After updating the IP address, it will connect. After this is done, we can use command line single line implementation to change the speed of the robot on each test.
Now we will initiate the Python SMB parser code. All we have to do is use Python SMB parser.py and we will initiate the code.
Once the robot is running, on the first computer, you will see the output of the multimeter producing the graph with 20 points per chart, seeing the erratic change, while on the second computer, we can see 4,000 points per chart, noticing a more linear progression over time. This video shows the erratic change, and as it decreases to a more linear progression over time as this 5-minute desk test continues. Once the data is recorded from the desk test, we can look back to the Raspberry Pi to see how the data is recorded.
The data is recorded on a front end called PageMyAdmin. To log in, we need to use root password Tor. Once we log in, we will use the battery study database. Within that database, we'll be using the SMB table to see the data log by the Raspberry Pi.
The following data was pulled from trial 1 of our battery state test. The GVR bot speed was set at 5 miles an hour for 60 minutes. Between the DMM and the SM bus, we recorded temperature, voltage, current, real state of charge, and absolute state of charge. Complications from this trial include the DMM stopping at the 49th minute and the Pi stopping at the 46th minute. We do not know the units for the data pulled from the SM bus. During testing, the GVR bot slowed down one or both tracks for several seconds at sporadic times. On the voltage readings from the DMM, we see a steady decline in voltage over time. Additionally, there are several high and low spikes throughout the capture. These spikes directly correlate to when the GVR bot's tracks slowed down during the trial. This is the raw data from the SM bus for voltage and current. This is the raw data from the SM bus for temperature and state of charge.
Here you can see our block diagram. Key things to note are in the top left, the robot system block, in the top middle, the power distribution block, in the bottom left, the data acquisition block, and in the bottom right, the data recording block.
In reflecting on this sprint, we were unable to fully complete our sprint goals due to planning for having 2 working GVR bots when we developed our roadmap, and with only 1 working GVR bot, we were only able to complete 2 of our 4 test plans. We updated the product roadmap to reflect these changes in our Sprint 3 and Sprint 4. Our current state to completion includes the predicted completion of testing, the predicted development of prediction model, the predicted testing of prediction model, the predicted completion of prediction model.
Our road forward for Sprint 4 includes implementing a web app to interface with battery data, conduct speed, load, power draw, incline, and surface testing, while utilizing 2 to 3 GVR bots to complete these test trials. We will complete all test trials in Sprint 4 to enable us to complete the prediction model before Sprint 5.